All right, so let's pick up where we left off. My computer died, so hopefully I'm able to put all of this together into one video. But if not, we'll still kind of give enough information to understand what's going on. So we're talking about the inverse sine function right now, the inverse trig functions. And so the main thing we need to remember is that for the inverse function, the inverse sine, we take the inverse sine of a ratio, and we want to know what angle has a sine equal to that ratio. Okay, so let's take a look at an example problem here. Problem number 9. The sine inverse of the square root 2 over 2 is basically asking, what angle theta in the interval from negative pi over 2 to pi over 2 has a sine of square root 2 over 2. So we go to the angles from negative pi over 2 to pi over 2. And again, just to review in case my video ends up cutting off the beginning part. Negative pi over 2 is in quadrant 4, or, it encapsulates here quadrant 4. And then positive pi over 2 would be rotation in this direction up to positive pi over 2. And so we're talking about quadrants 1 and 4. Is there an angle in these two quadrants whose sine is positive square root 2 over 2? Well, if we're looking at these two quadrants here, we can really take a look at the unit circle now. And so that I have that off to the side here. Let me make sure I'm sharing the correct thing. Yeah, so I have it off to the side here. And we can see that the y value here, the sine of this angle, is square root 2 over 2. So my answer is just pi over 4. That's the answer. As long as you're searching in the correct quadrants, because if we take a look at the entire unit circle, there is another value, another y value that has that is a square root 2 over 2, and that is a sine of 3 pi over 4. But 3 pi over 4 is not the answer, or not an answer to this question, because we are using the inverse sine function, which has a specific range, right? We mentioned the range of the inverse sine function is negative pi over 2 to positive pi over 2. It's highlighted there. And that means we restrict ourselves to quadrants 1 and 4 for the inverse sine, these two quadrants here. So not that one. Okay, not either of these two for the inverse sine. As we go through the inverse cosine, inverse tangent, we'll see that that might change. But inverse sine, we're talking about these two quadrants here. All right, very good. So let's take a look at another one. And this actually includes these two quadrantal angles here, positive pi over 2 and negative pi over 2. So let's try to show those. All right. So now what? Next one, the arc sine of square root 3 over 2. Let's go ahead and say what that is. The arc sine of the square root 3 over 2 is basically asking, what is the angle in, and I always like to use angle theta, we'll see why later, in negative pi over 2 to pi over 2 in the same two quadrants, since we're still talking about the inverse sine. The angle in those two quadrants where the sine of that angle is equal to the square root 3 over 2. And so what angle is that? Again, we're looking over here at these two quadrants. The y value represents the sign on the unit circle, so it's right there. Square root 3 over 2. So the angle is pi over 3. Okay. For this last one, I'm not going to write it down just to show how simple some of these problems are. Sine inverse of 1. Well, we go and we say, oh, here's the y value of 1. So the answer is pi over 2. Right? Didn't really take any work there, but we have to understand, that thing, the stuff that I've written there so far to help us find the answer. All right. Good. So let's go ahead and move on to arc cosine. To the arc cosine or inverse cosine function. And so we need to do the exact same thing as we did with the arc sine. We need to have a one-to-one function in order to be able to find its inverse. The cosine function is not one-to-one because it does not pass the horizontal line test. So we need to restrict the domain. And so how do we restrict the domain of this function? Let's suppose that we want to use the same domain as, the same restricted domain as sine from negative pi over 2 to pi over 2. Well, we can't do that this time because this piece here of cosine would not be a one-to-one function. It doesn't pass the horizontal line test. So we need a different piece. Well, how about from 0 to pi? That little piece there is one-to-one. And it also covers all of the values of cosine, all of the values in the range of cosine from -1 to +1. So, we can use that restricted domain. So for cosine, we'll say, we'll use the cosine function on the interval from 0 to pi. And so the range of this cosine function, the range is going to be, it's still -1 to +1. Okay, so I've skipped one of the pictures here, but in pink or whatever color that is, you can see that restricted domain for cosine, and then to find the inverse, we can reflect that graph about the line y equals x, and that will give us the graph in blue of the inverse cosine function. So a couple of facts about the inverse cosine function. Since we just stated the domain and range of this restricted cosine function, then the domain and range of the inverse should now be clear. We just swap them. So, it's actually all right here. This is from the textbook. The cosine with domain from 0 to pi and range from -1 to 1. We get the inverse cosine function. Its domain is from -1 to 1. And the range, very important here, this range is really important, is from 0 to pi. This is going to tell us what quadrants to look at when we're trying to find the answer to one of these questions. Okay, so let's keep that in mind. 0 to pi, what quadrants would that be? 0 is here, pi over 2 is here, and pi is right here. So with inverse cosine or arc cosine, we're going to be looking at quadrants 1 and 2. Okay, so a little bit different from the arc sine. And then finally, we'll do this one a little bit quicker. The arc tangent or inverse tangent function. Well, let's take a look at the tangent function. We'll have to restrict the domain. So let's call it f of x equals tangent of x. And we'll say on the interval from, and actually we need parentheses for this one, -pi over 2 to +pi over 2. We remember from last time in class, we said that at -pi over 2 and +pi over 2, the tangent function is undefined. So we'll exclude those values. But in between, the tangent function is defined in between -pi over 2 and pi over 2. And the range here of this function is all real numbers, negative infinity to positive infinity. So then when we invert this piece, this little piece that's highlighted in pink, that little piece there is a one-to-one function by itself. If we invert it, then we get this blue graph. And what would its domain be? Its domain would be all real numbers. Let's see. Trying to get it all in the frame here. The domain of this tangent inverse function is all real numbers. And the range is negative pi over 2 to positive pi over 2 without including those endpoints. Excuse me. And so that's very similar to sine. Okay, so that's kind of nice. All right. So let's go ahead and try a couple of these problems here. So they're getting a little bit more complex. And we'll kind of jump around on these. Okay, so let's take a look at this number 55 here. The tangent of arc cosine of the square root of 3 over 2. And so we're going to deal with the arc cosine first. So I might not even do some of these, so I'm just going to cross some of them out or just ignore them. I'm not going to do this one. So the arc cosine of the square root 3 over 2. Maybe I'll show how easy this is here just by doing this one fairly quickly. Um, the arc cosine is the angle theta in the interval from, now it's from 0 to pi because we're dealing with arc cosine, where the cosine of this angle that we're looking for is equal to the square root 3 over 2. And so just remember that 0 to pi, we actually just said it, but just one more time here, that is in these two quadrants, quadrants 1 and 2. So we're looking in these two quadrants for an angle whose cosine is square root 3 over 2. And so we can go to our unit circle. Now we're looking here, and we're looking at the arc cosine, so that's the x coordinate. And the square root 3 over 2, it occurs right here at pi over 6. So that means that the arc cosine of square root 3 over 2 is equal to pi over 6. And so we'll replace this arc cosine here by pi over 6. And this becomes a nice tangent of pi over 6 question. And the tangent of pi over 6, remember, tangent is y divided by x. And so we just look at the unit circle at the angle pi over 6, get the y value, 1/2, divided by the x value, square root 3 over 2. The 2's in the denominators, we can flip and multiply 1/2 times 2 over the square root of 3. So this is 1 over the square root of 3. If we rationalized square root 3 over the square root of 9, which is 3. That's our answer there. Okay, so this is getting closer to these problems here. Problem number 8, right? We have an inverse trig function, and then we're taking like the sine or cosine or tangent of it. All right, so as long as we know how to do each of these little pieces, we're okay. So let's practice a little bit more on these inverse trig functions. Let's take a look at number 58 next. 58. And so I probably won't do this one here. I'll just blot it out. So what is the cosine inverse of negative 1/2? Again, this is an angle between 0 and pi. So somewhere in here where the cosine is negative 1/2. So we're looking at the x value. The x value being negative 1/2. And it's this one here. So what's the angle there? That is 2 pi over 3. And so we can replace this cosine inverse of negative 1/2 by 2 pi over 3. And so now all we're asked for is the cotangent of 2 pi over 3, which is equal to, cotangent is x over y. And so for this angle, x negative 1/2 divided by square root 3 over 2 is equal to, oh, this is very similar, negative 1/2 times 2 over the square root 3. Yeah, this is similar here. It's just going to be negative, so it's going to be negative root 3 over 3. All right, there we go. And I'm looking at different screens here, so I didn't see that wasn't, showing. So, we did this piece here together, and then since the cosine inverse of negative 1/2 was 2 pi over 3, I just replaced this by 2 pi over 3 here, and then found the cotangent of that angle. All right. Let me double check something here, because I think I may have made a little mistake here. The arc cosine of square root 3 over 2. Okay, no, everything was good. Just wanted to double check it. All right. All right, very nice. So, let's go ahead and show problem number 69. Let's see here. Yeah, why not? It's a good exercise. And it will help us with, let's see, 69 is very similar to problem number 8. Might not look exactly the same. I mean, it looks very similar though. They both have an inverse trig function on the inside, and then it's the sine of that inverse trig function. Okay, so actually it's very similar to problem number 8. So let's go ahead and take a look at it. This one here, we won't be able to use the unit circle. And actually, we can actually do a bunch of these without the unit circle. But it could be easier. You would have to have some things memorized. So let's take a look at this one. This one, you can't use the unit circle anyway. So let's test our understanding here of these inverse trig functions by looking at this one here. What does this cosine inverse of negative 7 over 25 mean? This is an angle theta in the interval from 0 to pi, where the cosine of that angle theta is equal to negative 7 over 25. Okay, so let's go ahead and draw where 0 and pi are. Right now, 0 pi over 2. And so remember, we're restricted to quadrants 1 and 2. And so in which of these two quadrants would cosine be negative? Notice the cosine of theta is negative 7 over 25. It wouldn't be in quadrant 1, because remember that cosine is adjacent divided by hypotenuse. In quadrant 1, the adjacent is positive, but in quadrant 2, the adjacent side would be negative. This would be negative 7. The hypotenuse would be 25. And here we can have a cosine of negative 7 over 25. That's not possible in the first quadrant because both of those values would be positive. So let's go ahead and like that. Now, so the angle that we're looking at is this angle here, this angle theta. We don't really care about the angle, actually. We want to know what is the sine of that angle. I mean, we're talking about the angle here, but the specific value of the angle is not really of interest to us in this problem. We want the sine of the angle. Well, sine is opposite over hypotenuse. So we need to figure out this opposite side, let's just call it y, and divide by the length of the hypotenuse. So we can do this using the Pythagorean theorem. X squared plus y squared equals 25 squared. 49 plus y squared equals 225. And let's subtract y squared equals, if we subtract 49, that's like subtracting 50, but not quite. And then if we take the square root, then officially, plus or minus, there are two solutions to that equation, but since we're in quadrant 2, the y value is positive, so this is positive one square root of 176. Okay, so that has a value of square root 176. And so the sine of the angle theta, we've drawn the angle in quadrant 2. The sine of that angle is square root 176 over 25. And that is our answer. Okay. Remember that this cosine inverse represents an angle. So it completely makes sense to take the sine of the cosine inverse because the cosine inverse represents an angle. And we take the sine of angles. All right. So let's go ahead and do one more. There's one here in 8b where it has like a little variable there. That variable doesn't really matter too much. And it also does say evaluate each expression by drawing a right triangle and labeling the sides. Simplify as much as possible, but leave your answer in exact form. Okay, so let's try number 73. This one also has a variable in it, and it'll give us a little bit more practice using the arc sine. Okay, so what is this arc sine here? Arc sine of 3x over 5 is an angle theta in the interval from negative pi over 2 to positive pi over 2, where the sine of that angle theta is equal to 3x over 5. Okay. And so now we can ask ourselves, okay, well, let's see, negative pi over 2 or positive pi over 2 in that interval. Which of those two quadrants are we in? We're not really given a clue as to whether x is positive or not. So let's just do it in quadrant 1, and then maybe we can do it in quadrant 4 and see if the answer will be any different. If we said this angle is in quadrant 1, let's assume that x is positive. So the angle theta is this one here. Let's draw a little triangle. And the sine of this angle is 3x over 5. So that means opposite over hypotenuse is 3x over 5. We can use the Pythagorean theorem to find the missing side length. Let's call it, for right now, let's call it b. So 5 squared is equal to b squared plus 3x in parentheses squared. Let's solve for b. So this is 25 equals b squared plus 9x squared. If we subtract 9x squared from both sides, then we get, I'm going to flip things around here, b squared equals 25 minus 9x squared. and then take the square root. B is equal to, officially here there's a plus or minus sign, there's two solutions, positive and negative square root. But since B is to the right, then we'll take the positive square root, 25 minus 9x squared. And so let me erase this little b, or just cross it out. The square root of 25 minus 9x squared is the length of the other side. Okay, so then now we want to find the cotangent of that angle. The angle has been drawn. The opposite side, the hypotenuse, were labeled. The adjacent was found. And so now we can find the cotangent. If you remember SOHCAHTOA, tangent is opposite over adjacent. So cotangent is adjacent over opposite. And so that is square root of 25 minus 9x squared divided by 3x. And we're done. Okay. It's a very similar process for the one in the 8b. All right. Let's go ahead and move on then. And so the next part of this worksheet is problems 9 and 10, which are just solving equations that have trig functions in them. And so it's going to be very similar to just solving algebraic equations, but then you deal with the trig function. We want to isolate the trig function and then solve the equation that results from that. So let's go ahead and take a look at this example here. They do this one really nicely in the textbook. So I kind of wanted to walk through it. Specifically, they actually give a nice little graph of the solution set. So let me go ahead and solve it, kind of to the side here, and we'll show, they do basically exactly the same thing in the textbook, and then we'll show how to do it with the unit circle, because they don't use the unit circle, but we can. Okay, so let's take a look at this one here. So the equation is tangent squared x minus 1 equals 0. So we want to isolate the trig function first, so we can add 1 to both sides. And we get tangent squared x equals positive 1. Then we can take the square root of both sides. But remember, there's two solutions, plus or minus 1. So the tangent of x is equal to plus or minus 1. And so that means that tangent of x is equal to positive 1, or the tangent of x is equal to negative 1. And now we can take a look at this equation here and say the tangent of what angle is equal to positive 1? Well, if we go over here to the unit circle, it's right here. The tangent, remember, is y divided by x. So the tangent of pi over 4 is square root 2 over 2 divided by square root 2 over 2. The tangent of pi over 4 is equal to 1. And so one of the solutions, x is equal to pi over 4, is one of the solutions to this equation is pi over 4. Now, where is there another solution to this equation? In this case, we're not dealing with the inverse trig function. At least I haven't written it out. So we just want to know the tangent of which angle is positive 1. And we're asked for all solutions in the interval from 0 to 2 pi. So we need to look at the entire unit circle in this case. And we can see that over here at 5 pi over 4, there's another solution to this equation, because notice these two values are the same. The x and the y value are the same. So when you divide the y by the x, you're going to get 1. And so another solution here is 5 pi over 4. Or x is equal to, let's go back here. There's another equation that we can solve, or that we can find solutions for. the tangent of which angle is equal to -1? Well, if we go on here, if you've practiced this a little bit, you may have seen that the tangent of these pi/4 angles comes out to either positive or -1. And so the tangent of 3 pi/4, notice these two values are just opposite of each other. Negative square root 2 over 2, and then positive square root 2 over 2. So when you divide them, y divided by x, you're going to get -1. So one solution to this equation is 3 pi/4. And then you can see that in quadrant 4, there's another one, negative square root 2 over 2 divided by square root 2 over 2 is -1. And so 7 pi/4 is a solution as well. So let's take a look at their solution here in the textbook. It's very similar. I mean, the steps were all the same. You add the 1 to the other side and take square roots, and then you get a plus or minus 1. And so they approach it this way. You get this equation where once I got this equation here, I just look at the unit circle and find the answers. They apply the inverse tangent function to both sides. And then they say, okay, well, what's the inverse tangent of 1? What angle has a tangent of 1? And that's basically what we did. That's pi/4. Now, since we are asked for all solutions, from 0 to 2 pi, we can keep searching the unit circle. I didn't get into principal roots just to try not to make this video too long. It's already a bit long. And there's still more to go. So, if you want to know more about it, visit the office hours or, or read the textbook. That's always nice too. But notice that they also find the solution of 5 pi/4, right? And that was the other one that we mentioned earlier. And then they do the exact same thing with the other equation. They apply the tangent inverse to both sides because tangent inverse and tangent are inverse functions, so they just produce x. And then if they apply the tangent inverse to both sides, then they get negative pi/4. Which notice, negative pi/4, that's not between 0 and 2 pi where we want our answers. So they end up converting this angle here and getting 7 pi/4 and 3 pi/4. Okay, and those are the same ones that we got. So, nice little solution there. And then you can see the graph here. One period of tangent is from negative pi/2 to positive pi/2. But they wanted all solutions in the interval from 0 to 2 pi. Oh, wait, where's 2 pi? There it is. Yep. And so you can see on that green interval, the line y equals 1 and y equals -1, you can see that tangent takes on those two values 2 times each. So there's a total of 4 solutions. So I like the graph. It's kind of nice. You don't need the graph, but you can see that there would be multiple solutions that way. All right, so let's go ahead and take a look at another one of these problems. And I think some of these are really similar to, let's see. So I won't do the ones that are the same as the worksheet, just to give you a chance to try them. And there are solutions to the worksheet, so you can go check those out yourself. Give them a try on your own. The ones we'll do are very similar, so we'll still figure out how to do these. All right, let's go ahead and take a look at 2 of these. Okay, so and it says find all solutions in 0 to 2 pi. So let's take a look at this one first. So 6.2 cosine of x plus 4 equals 7.1. Hopefully this isn't too complicated. I didn't do this one in advance here, but we'll pull out a calculator if we need to. These are textbook problems, so they might require a calculator. Where in class we make the numbers nice so that they don't. Okay, no, this is gonna be nice. Okay, so we subtract the 4 on both sides, divide by 6.2, and the cosine of x equals 3.1 and 6.2. You can see that one is twice as big as the other, so this is 1/2. And so we want all angles from 0 to 2 pi, where the cosine of that angle is 1/2. And so now we go to the unit circle. Where is the cosine equal to 1/2? Oh, right here. One of the solutions then is x equals pi over 3. And then right here, 5 pi over 3. And remember, we were asked for all angles in from 0 to 2 pi. And so that's it. Those are all of our answers. All right. Oh, excuse me. All right, let's take a look at one more. We'll do the one with the fraction. Why not? Let's see here. So number 33, 2/3 cotangent of x minus 5 over 6 equals negative 3 over 2. Now the cotangent or tangent ones maybe are not as easy because sine, okay, that's just the y value. Well, that's just the y coordinate on the unit circle. Cosine, that's the x coordinate. Tangent, cotangent, you got to divide a couple of them. You got to divide y by x or x by y. But that's okay. We'll figure it out. All right, so let's see here. Excuse me. The first thing that I would do on this problem here is I'd multiply by 6. If you're in my class, you know that I don't like dealing with fractions, so let's just multiply by the least common denominator and right at the beginning. And so what do we get? We get 12/3 cotangent x minus 30 over 6 equals negative 18 over 2. If we chose the least common denominator, correctly, then all of these should reduce down nicely here to some nice whole numbers, which we get. And then I can add 5 both sides. And I get 4 cotangent x equals negative 4. Finally divide, excuse me, by 4. And I get cotangent of x equals negative 1. All right, nice. Cotangent of x equals negative 1. We've already seen this problem, like I said earlier. Hopefully you recognize, oh, well, when the tangent is 1, that's a pi over 4 kind of angle usually. Now the cotangent is going to be very similar. So cotangent of x is equal to negative 1. So we just want to know, remember, if tangent of x, or tangent of theta, let's see. That's y over x. Cotangent of theta is x over y. So we want to find out where the x coordinate divided by the y coordinate is equal to negative 1. Okay, well, that's going to occur. No, not right here at pi over 4, because that would be positive 1. But if we go over here, yeah, at 3 pi over 4, this is where the x coordinate divided by the y coordinate would be negative 1. So one of the solutions, x is equal to 3 pi over 4. And then the other solution, if we look across here, 7 pi over 4, x divided by y, those are opposites. So 7 pi over 4 is our other solution. Those are our two answers. And we're done. So not too bad. Not too bad at all. All right, and then the last one here, might as well do a problem like this. We already did one. The first example was actually like this one. It's basically just solving equations, but the trig function is squared. That just means if it's squared, that usually means there's just going to be more solutions. So as you saw in example 1, the first of these examples, the one that had the graph in it, there were 4 solutions, right? So when it's squared, that means that they're, excuse me, usually there's more solutions that way. All right, so let's make sure we don't do the ones on this page here. Okay, these are actually very, or somewhat different here. So, yeah, we'll still skip this one here. And we'll skip this one here. And why not? Let's do one that has like cosecant in it. All right, so we'll do 39, and this will be our last example. So -4 cosecant squared x equals -8. Okay, so how do we do this problem here? We want to isolate the trig function. So we'll divide by -4. And we get cosecant squared x equals, what is that equal to? 2. And so a couple of ways to do this. Let's see. One way that we could do this is by taking the square root of both sides. Let's take the square root. And so that gives us a plus or a minus. And so we get cosecant x equals plus or minus the square root of 2. In this case, the instructions were not printed on here, but we want every solution in the interval from 0 to 2 pi. So now cosecant, though, well, that's the reciprocal of sine. So we could also write this cosecant x as 1 over the sine of x is equal to plus or minus the square root of 2 over 1, and then do the reciprocal of both sides. So sine of x is equal to 1 over plus or minus the square root of 2. And if we rationalize this, we can do that by multiplying by the square root of 2 on both the top and bottom. And so we get sine of x is equal to square root 2 over 2, and we have a plus or minus sign. So basically, we're looking for all angles, all values of x. In this case, that would be an angle since we're taking the sine of it, where the sine is the square root of 2 over 2, or the sine of x is equal to negative square root 2 over 2. And that is not too hard to find. There are 2 solutions to this equation here and 2 solutions to this equation. Let's find them on the unit circle. The sine of what angle is square root 2 over 2? The y value needs to be square root 2 over 2. That's this one here. X equals pi over 4. Oh, here's another y value that's square root 2 over 2. That's 3 pi over 4. Or x equals negative square root 2 over 2. That would be 5 pi over 4. And then here's another y value of negative square root 2 over 2. 7 pi over 4. And there we have it, our 4 solutions. All right, a lot of pi over 4 is coming up today. Yeah. All right. Let's see, how much time is that? And just in case the beginning of my video gets cut off because my battery died, we'll do one more. Let's do one more. And you can turn this off if you're tired. All right. We'll minimize that. Let's do one. Hopefully it doesn't come out to the pi over 4 again. Let's try number 40. 6 root 3 cosine squared x equals 3 root 3. This was not one of those things, is it? No. Oops. Oh, what happened there? Okay. So this one here just takes 2 steps. Divide. This is the square root 3 is canceled, so it's just 1/2. And then take, oh no! We take the square root. What is going on here? We take the square root. Yeah, this is going to be very similar. Why do these pi over 4 angles keep showing up? Cosine x equals plus or minus, and then 1 over the square root of 2 which is just plus or minus square root 2 over 2. Okay, so again, the answers are still going to be those same pi over 4 ones. Wow. X equals, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Because, we're looking for the cosine of some angle whose, or some angle whose cosine is square root 2 over 2. So that's the x value being square root 2 over 2, or negative square root 2 over 2. That's the exact same angles there. Oh man, I was really trying to avoid one that had that. So let's try one more. Let's take a look here. Yeah, this is really the last one here. Let's hope that this one doesn't come out too. Yeah, we'll just do the next one, number 41. Actually, yeah, let's do number 37 here. I think I can tell. Hopefully this one is not going to come out that way. -7 tangent squared x equals -21. Okay, so, oh, this one's a little more challenging too. Let's divide by -7 on both sides. Tangent squared x is equal to, what do we get here? +3. And if we take the square root of both sides, then we get tangent x is equal to plus or minus the square root of 3. Here we go. So now we want to know what angles have a tangent of square root 3 or a tangent of negative square root 3. Okay, now it's a little tougher because we need to find, excuse me, a tangent of square root 3. So that's either going to be, we can see there's a square root 3 here. So tangent, let's just find the tangent of pi over 6 and see what it is. Let's see, because there's a square root 3 here, let's find the tangent of pi over 6 and see if it comes out to square root 3, and maybe this is one of our solutions. Let's see. The tangent of pi over 6 is equal to, so remember y over x, the y coordinate divided by the x coordinate, so 1 over 2 divided by square root 3 over 2, and the 2's kind of cancel, you get 1 over the square root of 3, not the square root of 3, right? It's the reciprocal. So if you wanted to rationalize this, you could, but it's not the square root of 3. So no, that angle does not work. The pi over 6 is not a solution. So, well, let's see here. Square root of 3 comes up here again in pi over 3. So let's try that one. Let's try to take the tangent of this angle. And you might be able to tell that this one is going to work, because if you know tangent well, then tangent is y divided by x. These denominators of 2, when you divide them, they're going to cancel each other out. And so the tangent of pi over 3 is equal to square root 3 over 2 divided by 1 over 2. And that's equal to the square root of 3 over 1, or just the square root of 3. So pi over 3 works. So x equals pi over 3. That is one answer. Now, is there another angle whose tangent, whose y divided by x is going to be positive square root of 3? The answer is yes, and it's this one down here, 4 pi over 3. If you take a close look at this, you can see if I divide this number, it's negative. By this number, it's negative. The negatives will cancel. The 2's in the denominators are going to cancel each other out as well, and so you get square root 3 divided by 1, or just square root 3. So 4 pi over 3 is a solution as well. And then our other equation, where tangent of x is equal to negative square root 3, well, we can go and look at this angle right here, 2 pi over 3. If we divide this number by that number, we get negative square root 3. So 2 pi over 3. And then any other ones, right? This one here, 5 pi over 3. If we divide this number by that number, we get negative square root of 3. So 5 pi over 3 is a solution as well. 4 solutions, and finally they weren't pi over 4. And its angles there. And so just to quickly, I'll mention this here really quick. So how are these angles related? Pi over 3, 4 pi over 3, 2 pi over 3. So pi over 3 is right here. It's 60 degrees. If you take a look at 2 pi over 3, its reference angle. We didn't talk too much about reference angles because we have the unit circle. We didn't need to talk about them as much, but the reference angle, if we were to, this is 120 degrees from the positive x-axis to this angle, but if we were to drop, perpendicular, little line segment here down to the x-axis and measure this angle that it makes, that the terminating side makes with the x-axis, that would be 60 degrees, the same as this original angle. And then the other solution, 4 pi over 3, same thing here. If we were to drop a perpendicular and measure this angle here, that would be 60 degrees as well. And then finally, our last answer was 5 pi over 3. What's 300 degrees down to 360? What's this angle here? It'd be 60 degrees as well. All four of these solutions have the same reference angle, for whatever that's worth. All right, I think that's the end of our little set of problems. So hopefully, that helps out a little bit. You can go back and watch some of the beginning parts. I know some of these inverse trig functions sometimes might be a little challenging, but yeah, it takes a little bit of practice. So do a couple of problems, do a few problems, and then you'll get the hang of it. All right, so thank you for watching this video, and I'll see you at some point, um, in class. Sorry for missing the in-person lecture, but I got a little bit sick, and so I had to miss a day or two. All right, so see you in the next see you next time.